In this lecture, we studied the adapter pattern. Let's first review in the abstract factory pattern, how did we make an algorithm reusable for different data types? Well, first, we design an algorithm class so that it works with an abstract data interface. And then for each existing data classes, we create a new data class that will inherit from both the existing data class and the abstract interface class. And then we use the data and functions in the existing data class to implement the functions defined in the abstract interface class. And then in this way, so an object of the new data class and an object of the algorithm class will be able to work together. So this new data class is called an adapter. We use adapters often in real life, right? When two things cannot work together, then we make an adapter so that they can work together. So here we have an algorithm class that can work with some interfaces, but the data class may not have those interfaces. And we do not want to modify the existing data class so that it will have these interfaces. Instead, we make a new data class. This new data class will inherit from both the existing data class and the interface class. And we use the data and the algorithm the functions. We use the data and the functions in the existing data class to implement the functions defined in the interface class. Basically, use the data and the functions in the existing data class to implement those interfaces that the algorithm requires. And then, so that's why this an object of this new data class and an object of the algorithm class will be able to collaborate. And a common use of adapter pattern is using third-party libraries. So there are many third-party libraries, and each has their own interfaces, although they may implement similar functions. So to make your application reusable for different third-party libraries, what you can do is you design your application to work with an abstract interface class. And then for each third-party library, you design an adapter class. Let's take a look at this example. So here we have a bubble sort class. It has two algorithms, sort in the decreasing order and sort in the increasing order. And these two algorithms works with this sortable vector interface, right? This abstract class, this interface class, has three pure-true functions. And we may have this existing data class called student vector. This existing class does not have these interfaces. So this data class does not have these interfaces, and this algorithm requires the data class to have these interfaces so that the algorithm can work with the data. In this case, as we said, we do not want to modify the existing data classes. Instead, we write a new class. We design a new data class that will inherit from both the existing data class and the interface class, and we use the data and the functions in the existing class to implement these interfaces. And here we have two data classes inherit from both the student vector and the sortable vector, and they have these two functions in common, get size and swap. So we refactor this common code into the a base class called student vector sortable, and then the student vector sort by first name inherit from this class, and this student vector sort by GPA inherit from this. So in this way, an object of this derived class and an object of this derived class, they will be able to work with these bubble sort algorithms, these two bubble sort algorithms. So there are two ways to do adaptation. One is called class adapter, which is also called multiple inheritance. Basically, we have a class adapter that uses multiple inheritance to adapt basically one interface to another. So here we have a target interface, and here we have existing class. We basically use an adapter inherit from both, and then use the data and functions in the adaptee class to implement this interface. Another way to do this adaptation is called object adapter. In this adaptation way, we have a class inherit from this target interface, and then in this derived class, we define an object. We instantiate an object of the adaptee class, and then to implement this interface, we basically use this adaptee class. To implement this interface, we basically use the data and functions in the adaptee object to implement this interface. Let's take a look at these two adaptation methods and see what are the differences. So for the class adapter, in this adapter, we basically expose the interfaces of the adaptee to the clients. Basically, adapter can be treated as an adaptee. Basically, the adapter class inherits these interfaces of the adaptee. And then the clients, because the clients will instantiate an object of this adapter class, the client can directly access the public methods defined in the adaptee class. And also, using this class adapter, we allow the adapter to be used in places when we expect an adaptee object. Basically, we can use a pointer or reference to this adapter object in the places that we expect a reference or pointer of the adaptee. And for this object adapter, so this one does not expose the interfaces of adaptee to the clients, because this adapter class only has implement this interface. So the public methods of the adaptee class, the client cannot call them from on this adapter object. And sometimes in places that adaptee is expected, so the adapter class may need to provide a function, say get adaptee, and return a pointer to the adaptee object, because this adapter class has an attribute or data member of the adaptee object. So these two ways of doing adaptation both works in reality, and which way you choose depends on the application. And this one, as we said in this adapter class, in this class adapter, we basically expose adaptee functions, the interfaces to the clients, and this one does not. Let's take a look of how this we have learned 3 design patterns, and now let's review how these design patterns avoid making changes to existing classes. For the abstract factory pattern, you see that we can add new data types to existing algorithms without changing the algorithms classes, and we can add new algorithm classes without changing the data classes. And for the template method pattern, we can add new versions of the template algorithm without changing the template algorithm. And for the adapter pattern, we can make objects of 2 classes collaborate without changing any of the 2 classes. Originally, they cannot work together, so instead we basically make a new class. This class will inherit from both the existing data class and the interface, and use the data and the functions in the existing class to implement these interfaces. Also, typically design patterns promote software reuse. Now let's take a look at how these three design patterns promote software reuse. For the abstract factory pattern, remember we reuse an algorithm for different data types. And for the template method pattern, we reuse the template algorithm in the base class for different versions of the algorithm. And for the adapter pattern, we reuse the adaptee class instead of writing everything from scratch again.